I'm Anil Kumar. Welcome to our class on advanced functions. We'll begin with the introduction. I would like Akshit to introduce himself.
My name is Akshit Candivanam. I'm practicing advanced functions with Anil sir so I can maximize my grades next year.
Great. Mohammed.
My name is Muhammad Husseini. I'm taking this class so I can learn the concepts in advance for when I go into grade 11 and get a head start.
Sure. Hamza.
My name is Hamza. I'm in grade 11 and I'm taking these advanced function classes to have a better understanding on the subject.
Ankita.
Hi, my name is Ankita. I'm going to grade 12 next year, and I just wanted to get a head start in advanced functions, so I'm taking this course.
Vishruta.
My name is Vishruta. I'm taking advanced functions to help me understand more.
Correct. So we are going to cover a lot today. I'm going to share with you the document. This is what we are going to do. We'll understand what are polynomials. Basically, we'll understand the characteristics of polynomials. The two things which are most important to give the characteristics of polynomials are degree of polynomial and the value of leading coefficient. When I say value of leading coefficient, it is whether it is positive or negative. So we'll see what is the end behavior of different types of curves. We'll look into the turning points. Do you know zeros and x-intercepts are different, right? Okay, Hamza, can you tell me what is the difference between zeros and x-intercept of a graph?
Sorry, I don't have. I think I know what it means. I don't have a good definition too. But the x-intercept is where the graph is crossing or where the graph is touching at the x-intercept.
Correct.
And about the zeros, yeah, I don't have a good definition.
Perfect. Okay, Akshit, can you tell me difference between zeros and x-intercepts?
Yes, sir. So I think, as Hamza said, the x-intercepts would be when the graph touches the x-axis, and the zeros would be what value produces zero for the function.
What else? Anybody else? Zeros are very special. Zeros are basically when you say zero, that means the value, the function is zero, correct? Like you remember the quadratic equations when we solved, we said this equation is zero, but in the discriminant, sometimes we get a negative answer and we say there's no real solution. But of course, there is a zero, right? It could be complex. So zeros could be real or complex. That is one part. When we get to polynomials, we are really looking into the real zeros. These real zeros are always the x-intercepts. However, they have one additional feature. At an x-intercept, we could have 1, 0, 2, 0, 3, 0, many zeros. For example, y equals to x squared. Y equals to x squared has an x-intercept at the origin, right? And also 0 at origin. But how many zeros at origin? X squared. 2 zeros at origin. Do you see that? And how is the graph of the function at origin? It is a parabola which turns at origin, correct? Because there are 2 zeros. Now let's look into the graph of y equals to x, which is a straight line. It has a 0. It has only 1 0 at the origin, correct? And it goes like a straight line. How about x cube? X cube has how many zeros at the origin? Tell me. 3. X cube, that means 1x, 2x, 3x, all 3 x's, right? Will give you 3 different zeros. All the zeros fall at origin. We say the order of 0 is 3 in x cube, order of 0 or multiplicity of 0 for x square is 2, and for x it is just 1. This order actually gives very different shape of the curves. For example, if it is a straight line, look at this straight line which I have drawn here, right? Straight line goes straight at the origin, perfect? But the graph of x cube, which is shown in black, it kind of goes like a saddle point. Do you see that? It kind of turns and then goes away. And parabola, you're very familiar with, it turns like a parabola, correct? So these are 3 different zeros, but all have common x-intercept, which is at origin. Do you appreciate the difference? Huge difference. So in our discussion, we'll more emphasize on zeros, right? And of course, when we graph, we are looking into the real zeros, okay? So those are important things to look into. So let's begin with what are polynomials. So what I've done here is sketch the graph of some of the polynomials. You will notice that all the graphs have a very smooth curve, correct? And domain is not restricted. X value can be any real number. The Y value for some graphs is all real numbers, but like a parabola, we could have some restriction on the range, right? Because it turns, so it can have absolute maximum or absolute minimum. Perfect. So let's see, what is the definition of polynomial? How does it look like? So polynomial is a function which could be written in this form. You see that it looks complicated to begin with. An x to the power of n, an minus 1, x to the power of n minus 1, like this, still a constant. Basically, you have been working with polynomials, like, you had ax squared plus bx plus c. Do you see that? This is a polynomial of degree 2. Highest power is 2, ax squared, right? That index, that power, that gives you the degree of the polynomial, correct? So, and a, b, and c are called the coefficients. C is a constant in this particular case, correct? So, an minus 1, an minus 2, these are the coefficients of different terms, correct? Now, for any polynomial, n, the degree has to be a whole number. It cannot be negative, right? Do you see that ax squared bx plus c? I could have ax to the power of 5 plus bx to the power of 4 plus 5. For example, all the degrees which I have, they're all whole numbers, right? We cannot have negative numbers. As far as the coefficients a, b, c, all those things are concerned, they're all real numbers. When that is the case, then we get a polynomial whose graph is a smooth curve as shown here, right? Which has no restrictions on its domain, correct? So that is how we have to see polynomials. So in general, the equation is f of x equals to as shown here, right? Where these are called the coefficients, which are all real numbers. So an minus 1, a0, this constant, they're all real numbers. Real numbers means we cannot have like sine x and all those things, but we have exact numbers like 1, 2, 3, 4. Square root 2 is a real number, right? So those real numbers. N is a whole number. The exponent cannot be negative, or a square root, cannot be a radical, okay? Cannot be a rational, but is always a whole number. Then you get a polynomial, correct? As shown here, you will notice these are the graphs of the polynomial. So if you punch in something like this in your graphing calculator, what you will see is a curve, which is kind of like this. What I've done here is categorize them into different groups, depending on the value of degree n and an. Now, this particular term, which is the term with highest power, gives the degree of the polynomial, right? So this is the leading term. It is most important term for any polynomial because it dictates the behavior of the polynomial, where n is the degree, right? So as I've written here, n, which is a whole number, is also the degree of a polynomial. If n value is 5, then it is quintic polynomial, degree 5. If it is 7, heptic 7, 9, nano. So they have different names also. You could like parabola, quadratic, right? 2. Cubic, 3 degree, right? So those are the terms. And an is called the leading coefficient. An is called the leading coefficient. Now, degree and leading coefficient decides how the graph is going to look like. And therefore, what I've done here is I've taken 4 different cases. Case 1, an is positive. Greater than 0 means positive. So I have, like if I write an equation, which is, let me write down one equation with numbers. Let's say we have equation 3x cubed plus 2x minus 1, let us say. So do you see that x cube, which is odd degree, right? And value 3, which is greater than 0. So the leading coefficient is 3 in this case, and this is greater than 0. If that is the case, the graph will be something as shown in the first graph. So you can just type out this equation on your graphing calculator and see the curve. It will look like this. However, if I make this negative, then it like flips on the x-axis and the graph will be kind of like this. Do you see the behavior now? It will flip, right? So that is the case when we're talking about the odd degree function. In the odd degree function, you see that the graph actually moves diagonally. You see it moves diagonally? Either it may go from quadrant 3 to quadrant 1, or it may go from quadrant 2 to 4, as shown here. If the leading coefficient is positive, in that case, right side is up. And the opposite end, the other side is on the opposite end. So we say end behavior of an odd degree polynomial is that the end behavior is like opposite ends. Both ends are on the opposite side. Right. Now let's look into the graph of even degree functions. Even means if I make this as, let us say, 6, this could be anything. If I make this as 6, in that case, if it is negative, the graph will go down as shown here in the fourth graph, one of those graphs, correct? All the graphs in group 4, they are going downwards, right? And behavior is when x approaches negative infinity, y approaches negative infinity. When x approaches positive infinity, y approaches positive infinity. That is the end behavior. And that is the end behavior if the leading coefficient is negative, right? An is less than 0. However, when an is greater than 0, in that case, right side is up. Do you see that? Now, if you compare these two graphs, you notice that in both the cases, an is positive. If leading coefficient is positive, then the right side is always up. Do you see that? That is one thing to notice. Second thing which you notice here is that for odd degree, opposite ends, for even degree, same ends. Both up, both down. You get the idea. Do you understand this part? Okay, let me summarize this. I'll just put them now differently so that this part becomes absolutely clear. Okay, before coming to questions, let me just show you. Where is that gone? Okay, this is here. So let me show you the end behavior right here. So what I've done here is kind of summarize. So the degree could be either even or odd. We know that degree n is just a whole number. So whole numbers could be even or odd. If it is odd, in that case, do you see opposite ends? In both the cases, do you see opposite ends? Odd degree means opposite ends. If it is even degree, both are same ends. Do you see that? That is one thing to be noticed. Second thing, if an is positive, so now look into this part, positive leading coefficient. You will see that it is right side is up. Do you see right side is up? The graph ends in quadrant 1. And if an is negative, then the graph ends in quadrant 4. Do you see that? Ending in quadrant 4. So that is kind of summary of end behavior for any polynomial. These are smooth curves as shown, right? So that is what it is. So this gives you an idea. From the degree and from leading coefficient, how do we decide the behavior or the characteristics of the polynomial, correct? Okay, with that, let's now get to some questions. I would like you to participate actively and answer the questions. They're very simple. Akshit, can you please read the first question?
Yes, sir. Which of the following relations are not polynomials?
Not polynomial. Tell me which are not polynomial.
So, sir, off the top of my head, I can see that A wouldn't be a polynomial.
A is not a polynomial.
Yeah.
Because we are
And-
signing. Yeah.
Right. And B wouldn't be a polynomial?
No, B is a polynomial. Square root 2 is a real number. What is not a polynomial? What
I think
else is not
E wouldn't be a polynomial because the 2 and then the x is right there. I don't think it's a real number. There's no exponent on the x.
Yes, -1, correct. So, and this is not a polynomial. Do you see? Because we have 2 to the power of x. It has to be a number, a whole number. We cannot have a variable there. This becomes an exponential function, correct?
Yeah.
So in this particular case, 3 of them are not polynomials, correct? Ankita, I'd like you to answer this question. Question number 2.
Which of the following do not represent a graph of a polynomial?
Yeah, tell me.
Is it A?
Yes, it is not a smooth curve. It has got corners.
Yes. E?
Yes, it is a cusp. This is called cusp. Yes, what else?
I think F.
Exponential function, correct? C, sinusoidal function. It has to go from one infinity to the other. Do you see that? That is very important. Sine function is also a smooth curve. However, its range is very much restricted between both the boundaries. In a polynomial, we cannot have both boundaries. We could have one boundary, right? Limit. One side will be infinity at least. Is that okay? So this part is actually very clear, straightforward. Question number 3, Vishruta. Can you please read the question and answer?
Complete the table with the degree and leading coefficient of each polynomial.
Yes. Tell me the degree of the first polynomial and its leading coefficient.
And the degree is 4. And the leading coefficient is
-1.
Correct. Second one, tell me fast.
Oh, sorry. Oh, sorry. I didn't know my mic was off.
Vishruta, tell me. Degree
5
of
and 7.
5 is the degree, correct, and 7. Yes. Next one, 3. Tell me the answer.
3 and 10.
That is the wrong answer.
Would you factor it first?
Or you just multiply. So we are looking into what will be the power of x, correct? So in this case, x square, then you multiply with x, it becomes cube. And this is like already cube, right? So it'll be, degree will be how much? Tell me.
4.
6. 3, 2 plus 1. Do you understand? 2 plus 1, 3, 3 plus 3, 6.
Oh.
Is this point clear to everyone? Hamza, is this clear to you?
Sorry, can you do that again? I thought you weren't allowed to add something that wasn't the same base, right? Like you can't add x squared and x cubed. Or...
You have to multiply all that, right? So we have x squared
Oh, okay, yeah.
times x
You
times
can multiply.
3x cubed. Do you understand? So
Yeah.
what is the leading coefficient? Vishruta, continue.
20.
How do you get 20 as the leading coefficient? 3 cube, right? 3 cube will be 27. Do you understand? So the leading coefficient is 27. So you are multiplying. To get the highest power, you will multiply all the x's, correct?
Oh, right.
X squared times x times 3x whole square. So I wrote 3 cube x cube, correct? 3 cube is 27. Very important question. So that is what it is. Okay, now, Mohammed, tell me the degree and leading coefficient for question number 4, part 4.
The degree is 6.
No.
So
Would it be 16?
Okay, so let's see. You have to multiply 3 by 2, so you get this as 3x square whole square. Do you understand? Whole cube. And then x to the power of 4 is there, and then x square is there. Do you see now? Tell me, what is the degree now? 6, 10, 12. Do you see that? And what is the leading coefficient? Multiply all these coefficients. 3 cube is 27. So in this case also 27 is the leading coefficient. You get the idea. Try the next one. Mohammed, answer the next one. 5. Tell me the degree, please. Yes, tell me. Just multiply these x's. Yeah, tell me.
Is it 15?
No. No. Okay, Akshay, tell me the degree for 5.
Sir, would it be 6?
4, 5, and 4 for this. 5, 6, 7. Do you see that 7? If you make 6 and it is 7, you get a wrong graph. Odd and even. Do you see that? Now tell me, what is the leading coefficient for this one?
Sir, would it be 3 to the power of 4?
Is it 81?
All are close, but they are not correct. Anybody else? What is the correct answer? Look at this, minus x. That is how a test question will be framed. You think it's such a simple thing? You will get a wrong answer. You have to multiply x squared with minus x with 3x to the power of 4 to get the right answer. This minus makes it negative 81. Do you see that part? So it is negative 81 as the leading coefficient. Is this part clear to everyone? Correct?
Sir,
Could be your question, but yes, yes, Akshay.
sir, so we only consider the variables when we're looking for the degree and the leading coefficient, right?
Leading coefficient, you can get highest power only if you multiply all the x terms, right?
Correct, yeah.
We don't have time to expand this and write the whole polynomial.
Yeah.
From the leading term, we get the graph. We are interested in that. Okay? Perfect. Now, so we just saw that the graph and end behavior definition. Hamza, I'd like you to read this slide.
Okay. End behavior of a function to see what happens to the graph as the independent value of the function approaches positive or negative infinity. Discuss end behavior from the following graphs of the polynomials.
Yes, discuss this particular graph. What have I shown you?
So as x approaches infinity, it's only about the red graph, right? I don't know why
In the
there's a
very
purple.
first, yeah, you only describe me this particular portion.
No, I'm talking about in the picture. It's only the red graph, right?
Yeah, yeah.
Okay. As x approaches, as x approaches positive infinity, y also approaches positive infinity for the first one.
Yes. And when x approaches negative infinity, y approaches negative.
Yeah, negative infinity, same thing.
Correct. That is how you're going to describe the end behavior. We know about all that. And this is how we are going to describe. Is that clear to you? So once again, if we have a positive leading coefficient, this is a very important slide. When x approaches negative infinity, you can see y approaches negative infinity. When x approaches positive infinity, y approaches positive infinity. We see when the degree is odd, both are on the opposite ends, correct? Whether the leading coefficient is negative or positive. If the leading coefficient is negative, it flips and the graph will be as shown here. When you're talking about even degree, in that case, when the leading coefficient is positive, both sides are up. So whether x is approaching negative infinity or positive infinity, y value is approaching positive infinity. However, when the x value is approaching negative positive infinity and the leading coefficient is negative, the graph goes from quadrant 2 to quadrant 4. Do you see that? So that is how we have to see the polynomial graphs, correct? Ankita, I'd like you to answer question number 4, please.
Write end behavior of each polynomial function.
Yes. First one. What is the degree?
The degree is 4.
Leading coefficient?
Leading coefficient is 2 or -1, sorry.
-1. So you have seen we are mainly interested in whether it is negative or positive, correct? As far as degree, we are interested whether it is even or odd, correct? We will know the end behavior. Now tell me, if the degree is even and the leading coefficient is negative, in that case, what happens when x approaches negative infinity? Y will approach what?
Y will approach negative infinity.
Correct, because both sides, correct? Same side. Is that clear to you?
Sorry, I just it just went out of my head. But how do you tell if a polynomial is an odd polynomial?
Yeah, next
You might have.
you answer for question number 2. Yes. Continue, Hamza. Answer question number 2. What is the degree of this polynomial?
Okay, so the degree is 5.
Leading coefficient?
7.
Positive, right? So we are only interested in positive or negative.
Oh, okay.
Yes, positive. Now tell me, When we know degree is odd, it means opposite ends, correct?
Yep.
If one goes up, the other goes down.
Hmm.
And leading coefficient is positive, right side is up. You
Yeah.
understand?
Yeah.
Right side is up, it will go to positive infinity, and that will
And
go to negative infinity. Does it make sense? How you
yeah.
right up?
Okay.
So we
I
will
did. Okay. Yeah.
you got the idea? Now,
Yeah.
Hamza, again try question number 3. Tell me, what is the degree of this?
Okay. X cubed. 3. Okay. X cubed, this would be 3. 9.
Multiply the x square is 2 plus 1, 3, and plus
3.
3, 6. Do you see that?
Oh, okay. Sorry. You add the powers. Okay. Sorry. Yeah.
Add
So
the
it's
powers
6.
and they get multiplied. Leading
Mm-hmm.
coefficient, is it positive or negative?
Leading coefficient is
All
positive.
positive. Do you see all
Yep.
x positive? No
Yep.
problem. Just
Nope.
see like this. Now I am looking at very clear. We're not interested in numbers.
Mm-hmm.
Positive or negative? Positive, even. Tell me what will be the end behavior.
So the y would go to positive infinity.
Both side, correct? You see
Yep.
that? So we'll just
Mm-hmm.
show like this now, right? Going up.
Mm-hmm.
Is it clear?
Yeah.
Mohammed, tell me about question number 4. First, what is the degree?
Um, is it
Tell me. 3 times 2 is 6. 6 plus 4 is 10. 4 plus 2 is 12. That is how you're going to calculate. Is that clear?
so yeah, so the 2 and the 3 you multiply,
Yes.
and then the 4 and the 2 multiply, you add them together?
Add them together. It's power of power you multiply, right? But when you same base kind of thing, x is the base for us. You add the powers, correct? So laws of exponent will be applied. Now, you see all the coefficients are positive. Therefore, the leading coefficient should also be positive. Is that clear to you? So tell me, what is the end behavior of this? Both
That
sides? Yeah,
it's
same.
going to approach negative infinity and approach positive infinity.
Both side up because it is even degree and positive leading coefficient. Is that clear? If it is positive leading coefficient, right side up, even degree, both up, both same side. Okay, Ankita, tell me, question number 5. What is the degree of this?
The degree is, does the negative impact
In
like
leading
the
coefficient,
one?
negative will impact in leading coefficient, but degree just count x. How
Okay.
many x are there?
7.
Yes. And leading coefficient?
Leading coefficient would be
Positive or negative?
negative.
Correct. End behavior.
Since it's negative, would it be going, y would approach negative infinity?
Yeah, right side down. Correct? And
Yeah.
since it is odd, opposite ends. Is that clear to you? Is this part clear to you?
Yes.
Everyone. Is this part clear to everyone?
Yes, sir.
Very important because we are going to now sketch the graphs based on this particular information, right? Let's move on. Now here, I have a graph for you. You need to tell me, looking at this particular graph, Mohammed, please read question number 5.
Provide information from the graph of the polynomial.
Yes, degree. Tell me whether it is even or odd.
Even.
Even. Sign of leading coefficient is positive or negative?
It's negative.
Why? Positive. Right side up.
Okay.
Only look at right side. If the right side is up, it is in quadrant 1, it is positive, right? Now, these are called the turning points. You see these points where the graph turns? These are called the turning points. How many turning points do we have in this graph?
3.
This is local minimum, correct? This is local maximum. This is local minimum, right? Local minimum means in the vicinity, in nearby area, this is the minimum value, correct? Overall, since it goes to infinity, we cannot have absolute maximum in this case, but we do have absolute minimum. This is the absolute minimum also, correct? So the range will be greater than 10 in this particular case, greater than equal to 10, correct? From the graph. Now tell me, how many local minimums are there? Mohammed, how many local minimums?
Sorry.
Yeah, it doesn't matter.
Well,
How
there's,
many local maximum?
and there's one.
Tell me the range of the function.
The range is gonna be from, it's gonna go from positive.
Maximum is at 10. So it is greater than equal to 10 from the graph. Is that clear? Above 10 in this particular case. Domain is all real numbers. Is this clear to everyone? Now, Mohammed, guess what should be the degree of minimum degree of this graph?
What should be the minimal degree?
Yeah.
So is that like the lowest point?
1, 2, 3, 4, 5, 6. What is the degree of this polynomial? What do you expect?
Oh. Maybe, actually, I don't really know.
Sir,
Yes.
The
Yes.
graph function.
sir, since it's even, shouldn't it be 2 as the minimum?
No, no, but this graph, 2 will be a parabola. This is definitely not a parabola. Minimum for this graph, yes, it is even. But what is the minimum degree for this graph? How do we figure this out? Okay, let me answer this question. You see number of zeros? There are 3 zeros. It has to be greater than 3, right? Now, these are linear zeros. They go straight. So 1, 2. And how about this 0? This is a quadratic 0. Degree 2. Do you see that? So total degree will be 2 plus 1, which is 4. Number of zeros will tell you the degree. There are 3 x-intercepts. However, the third or the first one of the x-intercept has got 2 zeros because the graph turns. So the minimum degree will be 4 and it is even. Does it make sense to everyone?
Wait, sir. So if the graph turns, it like exhibits like a parabola, right? So we count it as 2 degrees.
Yeah, yeah. So the 0 here has, so the 0 at -2. So 0 at x equals to -2 is of order 2. Or you can say order of multiplicity. We use 2 terms. The factor will be like this, x plus 2 whole square. Do you see if I want to write the equation? This will be the factor. And that 0, the factor will be x because it is linear. And the one which is at 2, that factor will be x minus 2. Do you see these factors?
Yes, sir.
Function will be 0 here. This will be 0 because of this. And for this, it will be this. Do you see that? So y will be equal to some a times this. That is your function. So I got the equation from the graph. You see that? I got the equation from the graph. Now, if I know one more point, in this case, I know this particular point, right? Knowing one point will give me the value of a. And so I will get equation from the graph. You see that how easily we got the equation? Is this concept clear to everyone? Hamza, is it absolutely clear?
Yes, it's clear.
One more example will do similar kind. Okay, that's more complicated. Hamza, please answer this question. Again, the same thing. You have to tell me from the graph what is the degree, even or odd.
Okay. So it's odd.
Yes, leading coefficient sign, positive or negative?
Negative.
No, right side up means positive sign.
Oh, okay. Yeah. Yeah.
Turning points. How many turning points do we have?
1, 2, 3, 4, 4.
Correct. Local minimum. How many minimum points do we have local?
2.
Maximum. So the turning
Yeah.
points and all will add up. Every turning point is either a maximum or a minimum local. Is that very clear to you? Now, tell me, possible equation of this graph, Hamza. Give me equation y equals to a times what? First factor. What will I, how will I write equation for this factor?
X minus 2, x plus 2, and then x minus 2.
No, minus 2 is a 0. But it turns like a parabola, so therefore it is of order 2. Do you get this idea? This 0.
I thought it was like a factor negative, so it would be x plus 2, x minus 2, like that type
No,
of a
no, no, no,
pattern.
no, not that. No, I'll change the color so that you know.
Sir,
Yes, yes, yes.
sir, following this logic, right?
Yeah.
Would the degree be 5? Because there's two parabolic changes and then there's just one.
Yeah. Degree कहाँ लिखा है? Odd लिखा है ना? हाँ. Yes, yes. Odd degree, it is 5. Will come. You're right. So the first factor is that x minus 2, since it turns, it has to be even. It could be 2, it could be 4. I could even write this as 4. Does make sense? Because it will turn. So minimum, if I say minimum, then you will put minimum value 2. Is that clear to you? Now, second 0 is at x. So this factor is x, whose degree is 2. And the third one is at 2. So what will be the factor for that one? Is that clear to you? This becomes my equation. It is called family of graph. When I write value a here, is that clear to you? How do I find the value of a? To find the value of a, I have to look for some other point. I already considered these 3 points to get the 3 factors. I have to now look at the third point, which will pinpoint and say, well, this is a very good point. I can say this is a very good point. Putting this value for x and y, I can calculate the value of a. Is this clear to you? How do we get equation from the graph? Is this clear?
Sir,
Yes, please. Yes.
I just have one quick question.
Yeah.
So you did x plus 2 because the point is translated to the left, right?
Yes.
2 units to the left, and then x minus 2 because it's on the right.
Yes.
Okay.
And or other ways, when will it be 0? We are looking at zeros and the multiplicity. This 0 is at minus 2. You get 0 at minus 2 if the factor is x plus 2. X minus 2 plus 2 will give me 0, correct? Absolutely clear? Now, let me say, if you count, you can say that the degree of this polynomial is 5, correct? Now, Akshit, I am making this degree as 7. It could be 7. If this degree is 7, then how will my equation change? Tell me. Which power should I make 4? Earlier I had made both of them 2, right? Look at the graph and tell me which factor will be of power 4. Yes. One of these. Why? And which one? Anyone? Out of these, which will be 4? Make a guess. Why? Sharper corner means higher power. So this should be 4. Do you understand the concept? No, sorry. Flat, sorry. This will be 4. Flatter. Think like this. If I have x square, and this is x square, and the power, this will be x to the power of 6, for example. Do you see? It will be wider. So it is wider at the origin, and therefore that should be of higher degree. So I could write an equation like this. I could also write an equation with this as 6. In that case, this degree becomes 9. But still, it is odd. You get the idea. So whether I make it 6, 9, or 4, or whatever, it can represent the family of the graph. Okay? But the important thing is it has to be odd degree polynomial. Okay? Another question. Okay. Uh, Vishruta, please answer question number 7. We have a graph. I would like you to tell me whether this degree is odd or even.
To me, it looks like it's even.
Why? Opposite ends. Opposite ends means odd. Okay. Sign, leading coefficient sign.
Negative.
Why? It is going to quadrant 1, correct? That means positive. So whenever you are heading to quadrant 1, always positive. Right side up. Do you see right up? An is greater than 0. Is that clear to you? Turning points. How many turning points it has?
1.
0 turning points. This is not a turning point. Do you see? It is not turning. It thinks it will turn, but it doesn't. You see that graph? If it turns, it will be a local maximum or minimum. This is called point of inflection. Let me write down. This point is called point of inflection. We'll use in calculus a lot. It is not a turning point, okay? Turning points were kind of like this. Do you see those turning points, maximum, minimum? This is not like that. It is not a turning point. So 0 turning points. So does it have a local maximum, minimum? No, it does not. So you could have a function whose graph is not turning at all. For example, y equals to x. Does it turn? No, it does not. Y equals to x cubed. Does it turn? It does not. This is kind of x to the power of 5 or 3, let us say. It doesn't turn. So these graphs do not have local maximum and minimum. So if I tell you to sketch a graph which does not have any local maximum minimum, that should be the type of graph, right? Do you get the idea?
Sir?
Yes, ask.
Sir, so what would be the degree of this graph?
It could be x cubed. It could be 3, 5, 7, because this is very flat. Do you see that? So we are saying it is odd, but we could figure it out if from a point. Is that clear to you? So if I say, well, this point is 1, 1, now 1, 1, it could be x cube, x5, whatever. Correct? So it looks like x cube. Akshay, please read this question and answer. Question number 8.
Yes, sir. Question number 8. Write possible number of turning points for a degree 7 polynomial. Sketch graph for each type.
All of you write down their answer and let Akshay struggle to give me the answer. Okay, Akshay, tell me. We have degree 7 polynomial. How many turning points will it have?
Sir, so for a degree 7 polynomial, right?
Yes.
So the degree is odd, right?
Yes. Degree is odd. You're right.
Yeah, so
How many turning points it can have? Minimum, maximum, possible. All possible I want. Anybody else is getting a clue? Please answer in between. Don't hesitate. Could this be degree 7 polynomial?
yeah, sir, we just went over that, right?
Correct. How many turning points it has?
0.
Perfect. Can you draw a degree 7 polynomial which has one turning point? Tell me. Can you draw a polynomial of degree 7 which has one turning point? We have to go from quadrant 3 to quadrant 1. If I turn once, then I have to turn once again, right? To land up there. Does it make sense to everyone? So we cannot have one turning point for odd degree polynomial because we have to go from one end to the other diagonally. So if you come back, it becomes even. We have to turn once again. So it is not possible to have turning point of 1, but we could have turning point of 2 as we have turned here. Is that clear to you? Let me draw a graph with this kind of a turning point. So I'll say, well, I go once here, but I turn like this. You see that? And sorry, let me do it again, please. Let me go like this first. I turn once and then I turn like this. Is that okay? So this could be degree 7. Now 1 0 here, 1 0 here, and 5 here. 5 zeros here. Do you see that? So I have 5
Sir,
zeros here, 1 0 here, 1 0. Yes.
sir, why would that be 5 zeros?
I want to make 7. A degree 7 will have 7 zeros. It may have different number of x-intercepts. All 7 can be at one place. Think like this, all 7 at one place or all 7 distributed. You get the idea?
Yes, sir.
Depending on that, if I have 2 zeros, then I have to turn once at least to get to the other 0. If I have the third 0, I have to again turn. That is how the turning points and the zeros are related. Got it? So now, from what you have learned and seen, can you tell me the possible number of turning points for a degree 7 polynomial? Yes, please. It could have 0. It cannot have 1, right? It could have 2 turning points, 4 turning points, and 6 turning points. So what you notice, for an odd degree polynomial, even number of turning points. Do you see? Even number of turning points. Because we are going from one quadrant to the other. In between could be n. Right? Let me draw like this. We have end behavior is kind of like this. Is that clear? So I cannot have one turning point because one turning point will lead me to the other quadrant, but I want to land up. Is this concept clear to everyone?
Yeah, so for example, for like a degree of 9, a polynomial degree of 9, it would have 0, 2, 4, 6, 8, just until.
Yes, 1 n minus 1. So that gives you the formula. So the minimum for an odd degree polynomial. So let's say odd degree, odd n. Is that okay? So minimum will be no turning point. You can go straight, correct? So from 0 to 2, 4, like this, to n minus 1. Is that clear? And obviously, n is odd, minus 1 will be even, correct? So you remember, minus 1, correct? Is that clear to you? So if it is 11 degree, maximum will be 10 turning points. Okay? Is that clear? Next question, please.
Sir?
Yes?
Oh, yeah. Okay, I was just going to ask for in even.
Answer this question now. Read and answer fast.
Okay, sir. So write possible number of turning points for a degree 6 polynomial, right?
Tell me.
So we said that an even degree polynomial has like odd number of possibilities, right?
Okay.
So, sir, would it be 1, 3, and 5? So 3 possibilities?
You nailed it. It has to have one turning point at least because it goes like horizontally, right? From 2 to 1. You cannot go from 2 to 1 without turning. Right? Or it goes from 3 to 5. It has to turn. And n minus 1 will be the maximum number of turning points. And therefore, for an even degree function, it will be 1 to n minus 1. So maximum number of turning points is n minus 1. Is that clear to you now? Now, can I ask you a question? Tell me if I have maximum zeros will be how much if n is the degree? Maximum zeros will be how much? For n degree polynomial. For quadratic equation, degree is 2. Maximum zeros, how many can you get?
2, sir?
2, right? So it is n. And minimum number of turning points, how do you decide the minimum number of zeros? I'm sorry, zeros. Minimum zeros will be how much? How can you decide this? Minimum zeros. It depends on odd or even function, right? Even degree. If it is odd degree, there has to be at least 1 0. But if it is even, there will be 0 zeros. We are talking about real zeros. Is that okay? I should have written x-intercepts. Is that clear to you? Is that clear to you?
Yes, sir.
X-intercepts. But if I write zeros, then what is the answer? For n degrees, zeros are n and n. These zeros could be real or imaginary. Is that clear to you? Quadratic equation, you have an equation, let's say, let's write down y equals to x squared plus 1. Does it have a real zero? No, because x squared cannot be minus 1, correct? It has two imaginary zeros. Is that clear to you? Not real.
Sir,
Yeah.
Sir, it's because it never touches the x-axis, right?
Yeah.
So
It never touches the x-axis. So no real zero, no x-intercept. But it has two imaginary zeros. It has two solutions. It is quadratic equation. It will have zeros. So number of zeros is same as the degree. They could be at the same place. They could be not on the real line. They could be on the imaginary line, as in x squared plus 1, right? So in the domain of complex numbers, it will have that much. Is that clear to you all now? Now here's the critical and thinking question. We are almost at the end. I would like Hamza to read this question and answer. Question number 10, please.
Okay. Write maximum minimum turning points for even degree polynomials and odd degree polynomials.
Good. Tell me. Maximum and minimum turning points for even degree polynomial. Tell me.
Okay, is it better if you can just sketch it at the bottom of?
You could, yeah. Sketch. And then
okay, so an even degree polynomial have one side.
yeah, and odd is kind of like this.
Yeah. Okay.
So you have to write maximum, minimum, and let us assume that n is the degree. Is that okay?
Yeah.
Yes. Tell me. Even degree polynomial.
Right. Maximum. So what does it mean? Does it mean how many points are there, or what is that question?
Maximum, minimum. I'm not saying all possible. So don't give in between, right? Just give me maximum, minimum.
I'm not sure.
Okay. Ankita, can you answer this question? Even degree polynomial, like a parabola, how many turning points maximum it can have? Minimum, even degree, if n is the degree.
sir?
I'm thinking.
Yeah.
Sorry.
Say, Ankita.
Sir, you can go.
Ankita,
Yeah, I
yes.
was gonna say 2.
Maximum turning points, you are saying 2. Okay.
Minimum.
No. If n is the degree, if n is the, let us say n is the degree, right? This is my polynomial, n degree. Tell me, maximum and minimum.
Oh, okay. I think I get what you're trying to say now. Okay.
Yes, Ankita.
I'm not sure. I'll have to think about this one.
Okay, doesn't matter. Akshat, answer the question.
Sir,
yeah.
I was gonna say for the odd degree polynomial, would it be n minus 1?
N minus 1 is correct for both. Maximum will be n minus 1, but minimum is different. For even degree, what is minimum? And for odd degree, what is minimum?
Would it be n plus 1?
No, it cannot be more than n.
Oh, sir, for
0 or 1.
For even, it would be 0, and for odd, it would be 1. Right?
It's the other way. See, you
Is it even degree is 1?
without turning, right? You can go without turning, correct? From quadrant 3 to 4. So for odd, it is 0 turns minimum. But for even, you have to go from across, right? So you have to turn. From one infinity you are coming, going towards the other infinity. You have to turn, correct? So 1 and 0, is this part clear to you? This is at least one turn. Do you see that parabola? You cannot draw a parabola without a turn. But you can draw x cube without a turn. Have a good look at it. Vishruta, do you understand this concept?
I need more practice, but I understand the general stuff.
No, this concept, this screen.
Oh, yeah.
Yes, very important. I'm telling you, very difficult for students to get this. Now, Ankita, I'd like you to read all this.
Zeros and x-intercepts. X-intercept is a point where the graph touches or crosses the x-axis. 0 is the point where the value of the function is 0. At any x-intercept, there can be more than one 0. 0 has a how do you say that word?
Multiplicity.
Multiplicity or order. It also decides the behavior of the curve at the x-intercept. Zeros can be real or imaginary. Polynomial of degree n will have up to n zeros. Solving equation means to find roots or zeros of the equation.
Is this clear to everyone? Yes? Now, if we have a linear 0, you have seen that the graph will cross the x-axis like a line. Do you see it is going straight? If it is even order 0, at the x-intercept, it will turn as shown here. Do you see like a parabola? Even degree means the degree could be 2, 4, 6, 8, whatever. And if the degree is odd, number or multiplicity of a 0 is odd, the order of a 0 is odd, then it goes like a saddle point. Do you see that saddle point?
Sir?
Yes.
So you said that point is called a point of inflection, right?
Yes. Another name is point of inflection. Another thing is, do you see x-axis is tangent? At this point, x-axis is tangent, right, to the curve. So I could ask a question, at which point the x-axis will be tangent to the curve. So it is at both. Turning point also it is tangent. Do you see it is tangent here? And it is tangent here also. The difference between the two tangents is one tangent is going through the curve. Do you see that tangent? Normally, how do you define a tangent? You say, well, I have a circle and a point which just touches at one point, correct? But do you see the tangent is going through the curve? So that is a point of inflection. Okay, so is today's lesson clear to everyone? Now, let us try to sketch one graph. Here is a function x minus 3 times x plus 1 whole cube times x plus 4 whole square. Who would like to sketch this graph? Tell me.
Sir, I can give you the degree. It's
Okay, degree. Tell me degree.
so degree would be 6.
Yes, leading coefficient.
The leading coefficient would be 1.
Greater than 0, right? So positive,
Yeah.
correct? That means positive means right side is up. Is that correct? Degree
Yes, sir.
means same ends, right? Is that part clear to you from this? Akshat?
Yes,
Right?
sir, that's clear.
Hamza, everybody, is this part clear? First thing you have to
Yep.
look at the degree and leading coefficient. And now let's get to zeros. Tell me, Akshat, what are the zeros for this? Zeros at x equals to what? Start from left.
Sir, so this is so it would be 1, 3, and 5, right, sir?
Minus 1. And zeros at x equals to minus 4. At these points, we have zeros on x-axis, correct? The first factor x minus 3 is 0 for x equals to 3, correct?
Yeah,
That
yeah.
means I will have a 0 at this point. I can plot my 0 here. Is that clear to everyone? The second factor x plus 1, when will it be 0? It will be 0 at minus 1. And the third one will be 0 at minus 4. Are these points clear to everyone? Now,
Sir,
yes. So, okay. So this is the graph which you need to sketch, okay? And check your answer using a graphing calculator. Perfect. Use what we have learned today. Is that clear to you? Good job. So we'll stop this screen and I'd like you to summarize your learnings. Ankita, can you tell me what did you learn today?
I learned about the polynomial functions, and I learned some new things. For example, the zeros and determining it from the actual function, as well as end behavior and the right side up, and knowing about the right and the odd and even functions.
Yes. Mohammed, can you summarize what did you learn?
I learned about how to get the degree. Something I still have to work on because it's still kind of confusing for me.
Go through this video I'm going to upload understand very important concepts. We actually covered 3 chapters today. Lot of material we have covered, right? Try to do questions from your book. Okay, Hamza, can you please summarize what did we learn today?
Sorry. I learned about like the degrees of polynomials, how to tell if it's even or odd, how to sketch it. All this. Yeah.
Vishruta, can you tell me what did you learn today?
I learned a lot of new stuff about the degrees and mostly polynomial functions, how to find from the equations, and the importance of zeros.
Perfect. Akshit, can you summarize?
Yes, sir. Today I learned a lot of new things that were like not introduced to me because I knew what polynomials were, but I never knew they could be graphed like that. So I learned about the even, odd, and like how like the x-axis plays like a tangent role when determining the polynomial functions. Yeah.
Good. So we'll end here. I'll upload the video. Also, go through the questions from your unit 3. Try to do as many questions as possible. If there's any difficulty, post me those questions, correct? Well, I'll help you out. But with today's lesson, I think you should be in a position to answer most of the questions in first 3 chapters of unit 3. Okay? With that, all the best and see you next time. Thank you. Bye.
Thank you, sir.